Uh, Hello, Professor. So we are from Group 22. Our team members are Sharing Lama, Lakshmi Priya Vemula, and myself, Shravani Manne. So today we are going to present about paper one, which is about uh, spike system. So basically, the spike system was developed by Space Telescope Science Institute, which works for NASA Hubble Space Telescope. So the scientific community initially places a premium on effective use of astronomical observatories due to their high cost and limited number. They are unique and unique and space based. It requires like space based efficient scheduling. Coming to the HST scheduling, since its inception is in 1990s, which is in April, so its HST's unmatched combination of wavelength coverage and angular resolution has transformed astronomy research. So despite of the manufacturing difficulties, HST could conduct research which will give some promising result. So in late 1993, the space shuttle has visited HST to replace the main camera with the second generation equipment. So proposers have their relative temporary constraints as their priority, and which leads to the scientific goal, which has leaded to them to the scientific goal. So the representation and combination of constraints and preferences. So the scheduler receives two types of information from constraints, which includes activities under specific conditions, because it cannot be violated routinely. So this type of constraint is referred to as strict or hard. And coming to the combination of preferences and suitability functions, if a task is involved, if a task involves a lot of constraints, it's crucial to factor in their degrees of preferences. And there are like several rules that analyzes evidences against various conclusions. So there are limitations to this technique to reasoning, such as the knowledge base should form a tree to prevent counting evidence twice. Coming to the consistency methods and computational aspects, there are these methods have demonstrated to be useful in both spike and discrete CSPs. So all these approaches are consistent, which implicit information visible. So there are certain strategies to help find out the timetable faster. So node consistency, they are like node consistency eliminates domain variables that cannot be included in any of the solution. So this is reflected in the formulation functions. If both activities are required to be scheduled in the interval, then they must have unit durations and be bounded to be scheduled with a minimum end-to-end spacing approach. And coming to these scheduling functions, the toolkit consists of four important factors, like conflicting assignments, logged and ignored variables, domain value removal and restoration, and constraint coaching. So these are all the constraints or the values without any violating constraints. So coming to the time sampling, To translate any activity into CSV variable domain, the scheduling interval for an activity is discretized. So if no natural time discretization exists, then it is required to examine how to represent time discretely. And after some practice with HST scheduling, there are certain options which will limit these constraints. So it all depends upon the limitations and the implications for each problem type. So the rest of the part will be continued by Priyanka.
Hi everyone. Today I'm going to discuss about the scheduling search and its flow in the Spike. Actually, Spike uses a new technique which is called as the multi-start stochastic repair. There are few steps involved in the scheduling search process. First step is the trial assignment and then repair, then deconflict. Trial assignment is nothing but it just giving a trial and error method. It's making an initial guess of the activities that are to be scheduled. And next, repair. After the set of activities have been scheduled, it just try to eliminate constraint violations using these heuristic repair strategies. And then the last but not least is the deconflict step. In this, it remove any actions that violate constraints and avoid conflicts. As the heuristic strategy applied in this Spike is stochastic, which means that all the above three steps can be repeated n number of times. And the two other factors which plays a major role in this Spike search process is the one optimization and other is the oversubscription. Coming to the next slide, in this slide I explained about the detailed description of those three steps. First, trial assignment heuristics. In this, for the repair based approaches, it selected good trial assignment, which is very critical, and to that end we conducted extensive trials on various combinations of variables and value selection heuristics to determine the most potent combinations. And in the repair heuristics, we used to count the number of constraint violations were applied on the scheduled activities or prospective schedule times. Then it is used by the Spike repair heuristics. One such repair heuristic is minimum conflicts time selection. In these, activities are shifted to periods when the number of conflicts is reduced. And coming to the next slide, deconflict. It says about the actually in deconflict, the Spike employs a very straightforward method to remove the conflict activities. And then next, after conflict, it scheduled qualitative measures. In this, the observations were made on the schedule and the total observing time schedule and the degree of the performance of the scheduled observations. These two are the main criteria for the scheduled quality. And then the last step in this process is the rescheduling. In this, task rescheduling is done in two ways. One is the task locking and another is the conflict cost analysis. Tasks or the set of tasks can be scheduled in advance and will not be considered during the search or any repair process. Coming to the next slide, Spike and HST science scheduling. Actually, this the corresponding figure illustrates about the HST scheduling process flow. It includes actually this HST processing flow will be carried in two phases. One is planning and pre-scheduling and other one is the scheduling. The steps, overall steps involved in this HST are: first one is proposal preparation, and the next is planning, and the next is long-term scheduling, and the final one is short-term scheduling. In overall, the proposals were submitted via the internet through a proposal database, which is called as PEP, proposal entry processor. And then transformation, which is also called as planning has been applied on these proposals submitted by the astronomer. Coming to the next slide, here each and every step has been detailedly explained. Was this in proposal preparation? This proposal provided by the astronomer will serve as the main source of information for the planning and scheduling process. Here the observation proposals are handled through the RPSS system, which is called as remote proposal submission system, and then it was entered into the proposal entry processor databases. And next, in the transformation or the planning process, an export system called transform the proposal into comprehensive task descriptions for scheduling from a higher level of specification. Coming to the next slide, it describes about the scheduling process, long term, short term. After the planning has been implemented, this long-term scheduling will start with a series of transformation, observing suggestions, which are represented with the scheduling units and their corresponding constraints. Next, coming to the short-term scheduling, it will take a span of time like a week, starting with the list of scheduling units called as SUs from the long-term plan, and create a calendar for the week worth of activities. Finally, implementation. To avoid uncoordinated modifications, developers employ code management tools, for example, Unix, and then procedures and techniques for delivering software modifications in a short time of amount of time also necessary for this implementation of this task scheduling. Next, coming to the next slide, Lama will continue with the next slides.
Hi everyone, my name is Chiring Lama. For operational experience, HST science operations is divided into cycles in which proposals are solicited from the astronomical community. Long-term cycle will consist of about 1 year of HST observing, while early HST operation consists of special phases, orbital verification, and cycle O. OV access the basic capacity of telescope and instruments. Cycle O observation contains a mix of scientific variations and guaranteed time observer observations. The spike system was first used to support HST scheduling for cycle O. Cycle O used spike in an active. Can we change the PowerPoint? Can you change the slide? Thank you. Cycle O use spike in interactive mode. Planners would display individual proposals on time display and choose times of high suitability for observation. True long-term planning begin late in cycle one, with schedules of approximately 3 months duration, and year-long schedules were first generated operationally beginning with cycle two, while the work was anticipated to cover 6 months duration and will be maintained beginning with cycle O. It was caused the late operation was caused due to a larger than anticipated rate of change of proposals prior to the launch. Less than or equal to 10% of the proposals were expected to change after submission, whereas the actual rate is nearly 100%. Can you move on to the next slide? Application of Spike to other astronomical scheduling problems. Spike has been adapted to schedule a variety of astronomical scheduling problems. The addition of Skype of these problems demonstrates the flexibility of Spike scheduling framework. For Astro D and XTE, Spike is operated in hierarchical manner. In hierarchical manner, long-term scheduling first allocating observation to weeks much as they are for the HST problems, and with similar types of long-term constraints at preference. Due to detailed minute-by-minute constraints of low Earth orbit operation, major changes were required to implement short-term scheduling. Can we move to next slide? The major change required to implement short-term scheduling were a new type of task that can be variable duration depending on when it is scheduled and which can be interrupted and resumed when targets are updated by the Earth or the satellite in radiation belt. A new classes of short-term scheduling constraints which more precisely model target occultation, star tracker occultation, ground station passes, entry into high radiation region, maneuver and setup times between targets, and interface between different hierarchical levels by which a long-term schedule constant times for short-term scheduling and conversely. A post-processor which examines short-term schedule for opportunity to extend task duration and thus utilize any remaining small gaps in the schedule to increase efficiency. So these were the major changes that were required to implement short-term scheduling. Can we move to the next slide? In summary, the Space Telescope Science Institute developed the spike planning and scheduling software in support of the Hubble Space Telescope as a general toolkit for planning and scheduling with the National Aeronautics and Space Administration, a powerful yet sufficient method to represent the wide variety of strict and preferential constraints encountered in real scheduling problems. We also have fast, efficient constant propagations and scheduling algorithms. Scarce flexibility has been demonstrated by adapting it for several other spacecraft missions and ground-based observatories, and by integrating long and short-term scheduling at different levels of abstraction. Thank you.